Good evening. In this video I'm going to try to show you how to use the third-party sensor library that works with RobotC. This is a pretty radical change from some of the work that we've been doing that uses just the built-in functions and will require a little bit of setup on your part and a little bit of different way of doing things. This is only necessary if you plan on using the raw sensor values to measure distance, so please don't go crazy with this unless you're at the point where that actually makes sense to do. The library was written by a gentleman who runs a website at Botbench, and you'll find he's pretty popular in the RobotC forums as well. And so we don't have to smash his website. I have gone ahead and put this up on Sakai. Windows isn't quite fitting here. So if you go to the robot section, there's now a RobotC optional drivers part. There's the zip file. You'll need to download this to your computer, and you have to extract it somewhere on your hard drive where you'll remember where it is. This is starting to get to configuration, so what you do won't necessarily match my screen. I'm running mine out of a Dropbox because I have to have this work at both home and in class. Once you've downloaded that library, you're going to want to unzip it, and you're going to come up with a like that. So it'll be whatever folder you unzipped it into, drivers folder, some help files, and a whole bunch of sample code. So this is get that unzipped, and now you have to tell RobotC how to use it, and that's going to be done in several steps. The first step is under View, Preferences and Detailed Preferences. Click on the Directories tab and find the Include files for Platform NXT. And you can go ahead and click your Browse button, navigate through to wherever you installed this. Don't actually click on the drivers part. You can. I've set my includes up where I don't do that. So to match mine, you would want to click this top-level directory that you extracted. And again, if you have trouble with this, this is something I can give you a hand with during our next class. You go ahead and click that, click on OK. It should set up a fairly long path. Again, obviously you don't have Andy in yours. And this is going to let you, this is how RobotC is going to know where to find these extra commands you're adding to it. So as usual, we're going to go up to our motors and sensors setup. Under sensor management, we have to allow custom design sensors. This activates the commands we're going to use. And you'll notice that I named them, but all three sensors end up with the same type. You're no longer going to set your sensor type here. You're going to actually use different commands to read the different sensors so you can get some customization out of this. So I've used the IR seeker, which I've labeled IR, the LEGO sonar sensor, which I've labeled distance, and the high technic color sensor. Yet all three have this same type. It wasn't clear from my experiments and reading the forums, whether it's how these can mix. Obviously, you want to certainly not use the built-in firmware to read the same output as this third-party driver, but I felt it was safer to just be consistent, and it's what I tested, and it seemed to work with no glitches. So again, I2C custom is the type that you're going to want to pick here. And this is the standard code that we have here. The next thing you're going to do is a little bit different, is you need to put these include files in. These are, what include means is going to tell RobotC, go read this extra bit of code that's in this outside file, and this is where this gentleman has written each of the components that you're going to need. And again, because of the way he has this set up, that's why I put drivers here, because these files are going to include even more files that contain the back-end communication for how to talk to the digital sensors. So that's sort of the setup component, and yes, there was quite a bit of that. So now let's actually take a look at some of the different code modes here. I'm going to store my base readouts, the direction out of the IR sensor, the distance in centimeters out of the sonar, and the color out of the color in these basic pieces. I'm going to set up an array. This is something I really didn't cover in detail in class. This is just a way of having a variable that works more like a spreadsheet, sort of. So in this case, think of it as a single column called raw, and I have 5 slots in it. The slots will always start at 0, so these are referred to as 0, 1, 2, 3, and 4. You've used arrays, all of the motor commands use them, but yeah, this is something I haven't shown you how to code before. These are square brackets if YouTube is making it a little bit blurry. So before I get into my while loop, I'm going to set the mode on the IR seeker. Again, as we've done in class, we're going to use 1200 pretty consistently, so this little line of code will take care of that. So instead of using the sensor value command, I'm going to go ahead and use these commands. This first command is going to read the IR ball using the filter that we've identified up here. There's a, I think it's called DC direction, but we're never going to use that, so this is the one you always want to pick here. And again, this is going to be the same as before. It's going to return a 0 if it doesn't know where the ball is, and it's going to return a 1 through 9, depending on the direction of the ball. Color works the same way. It's going to return the same integer as you had before. And distance is, again, read out in centimeters. So nothing here really changed. The commands look a little bit different. And again, when I put the sample code up, you can pretty much cut and paste these right out. The new command, the whole reason we did all of this mess, is we can now use this read sensor strength. It takes in the port, and then you must put in 5 variables. I put in the array just for convenience. Again, you could actually, if you didn't want to mess with arrays, you could name this, value 1, value 2, value 3, whatever. It doesn't really matter. So this is my code. As usual, I have a little stuff down here to make the warnings not pop up. So I'm going to go ahead and start this block of code. My screen blew up on me, so let me shrink this down and get everything where hopefully you can see it all in the video here. There we go. So I'm going to start my code. Everything should initialize. You'll notice that in this case, the ultrasound sensor, because it's not really detecting anything, is going to read a maximum value. I have this actually sitting over the blue tape is a pure coincidence, so that's why I'm getting a color value of 2. If I slide it sideways, I'll get my gray value and go back to blue. And the IR seeker is reading 0 because I have the ball turned off right now. So if I pick the ball up and hold it in front of the sensor, I'm about, I'll get a ruler out here, 12 inches or so apart. You can see I'm getting a values, in the mid ones. I'm getting a value 5. I can move it back and forth. You'll notice that where you get your value depends on where I am here. And you'll notice that the values when I'm on the right are just a little bit higher than on the left. I'm trying to keep the distance the same, and that's because I'm catching the shadow from where I've mounted the ultrasound sensor. Now you'll notice that as I move closer, this little number in raw 2, assuming I move straight enough, should be getting a little bit, kind of moves from the 150 range up into the 2 range. Now I'm unfortunately on top of a white table, so I'm getting a lot of bounce. So as I get real close, right now this is about 4 inches. I'm getting a value right around 200. So you really want this value probably around 210, 220. In the black room, you'll get a little bit better case. If your IR seeker is sort of not, bouncing IR off of the white plastic of the NXT brick, you'll get a better result if it's kind of off by itself a little bit. But this gives you the really basics of how to do. There are 2 strategies if you want to take advantage of this information. The first strategy would be to just look at raw 2 and trust your steering code is going to keep you straight in. That's certainly probably how I would do it. If you really want to measure distance independent of direction, then you would need to write a little for loop that would iterate over these values and basically pick the largest one. If you really wanted to be fancy, you could take, the largest one's the safest bet. If you're reading it from 2, it's probably not worth averaging. You probably want the larger one. So I hope that gives you a little bit of some suggestions on how to go about using the sensor. Again, I'll put this block of code up you can copy. I would not recommend mixing the old style and new style. If you were reading a light sensor, however, the light sensors and the touch sensors, these use the old analog protocols, and there's no need to run those through this third-party driver. Again, this is probably one of the more confusing videos I've had to put up, but watch it more than once, take a look at the source code, and if you have any difficulty, ask during office hours. Have yourself a great evening. Good night.